Pythagoras Pythagoras's theorem. That's really hard to say. Pythagorean theorem. There we go. Okay. So that was actually a person, and he made a discovery many years ago. So you can blame him for having to learn this. But what he discovered is if a triangle has a 90-degree angle, that's a right angle. So these are all the right triangles. So think about the corner of your room and you put a board right up against the two walls that are going out of the corner. So what happens is this big square that you can create from that side right here is actually equal to these two little squares, which are called the legs. So this is called a hypotenuse right here. It's the longest length of the right triangle. Is always across from the right angle. And then the legs are attached to the right angle. So if you take the area of the two leg areas, it's going to equal the hypotenuse area. Very interesting, very weird, and it's true. So that's called the Pythagorean theorem, or Pythagoras' theorem. Oh my gosh, I can't say this guy's name. Ooh, I would not want to have his name. Hey, Pythagoras. Oh, no. Okay. Anyways, so we can write his theorem as a squared plus b squared equals c squared, because they are, of course, squares. And that's how you find area of squares. So that is where this came from. Okay? So we have a squared plus b squared is equal to c squared. So if your teacher gives you a triangle and they say, is this a right triangle? Is this a right triangle? Question mark. And they just have some random numbers in there. Let's say it's a 4, 5, and 6. You can try to figure this out by actually just plugging the numbers in. So this one right here looks like the right part of the triangle. So let's plug in 4 squared plus 5 squared equals 6 squared, and see if 4 squared plus 5 squared is equal to 6 squared. So 4 times 4 is 16. Why is my... You're all so thin. Am I like... Okay, hold on. Ew, I see. Okay. I was zoomed out. That's why everything looks so skinny. Let's make it a little bit bigger. There we go. So we have 4 squared plus 5 squared equals 6 squared. Okay, let's make up some room here. So is this a right triangle? Well, 4 squared really means 4 times 4. If you have anything squared, so if it's 2 squared, that means 2 times 2. If it's 3 squared, it means 3 times 3. You're multiplying 3 times itself 2 times. Okay? So let's go ahead and do 4 times 4, which is 16. 5 times 5 is 25. And 6 times 6 is 36. So if we're looking at that, let's do 25 plus 16. So 6 plus 5 is 11. 2, 3, 4. We have 41 equals 36. Is that true? No. So this one is not a right triangle here. Nope. So when you have questions like that, because I know in geometry they do have questions where they say, is this a right triangle? And they give you random sides, like 4, 5, 6, 3, 4, 5. That's what you can do, is just plug it into this equation. Actually, let's just clear that. Okay, so moving on. Okay, so in geometry, they will also have you solve for missing hypotenuse, whatever that would be. Missing sides, let's just say that. So they're going to say, here is the triangle. See if I can make a right triangle. Okay, there's my right triangle. Here's a triangle. I want you to solve for your C, and I'm going to give you two sides, 5 and 12. What is your missing side? So what you're going to want to do is just simply plug it in, because as long as you see this little guy right there, the easiest thing you can do is immediately say it is a right triangle. I can plug it into a squared plus b squared equals c squared. And you can always find your hypotenuse. Mia! Sorry, my dog is barking. By going straight across from the right triangle, the right angle. So this means it's a leg and a leg. And if you remember from the picture, let me see where the picture goes. A is the smallest, then B, and then C. I don't really tend to make my students put it in any order. You can do A, B, C, or A, B, C, whichever one you prefer. So 5 squared plus 12 squared equals C squared. So from here, you're just using simple algebra to solve for C. So 5 times 5 is 25. 12 times 12 is 144 equals C squared. So let me move this down. So 144 plus 25, 169. Okay? Now, some people have a really hard time with this little square. They'll say, well, I just solved for C. No, we want to know what C is by itself. There's no square on here, right? So how do I get rid of this square? So the simple answer is we have to get rid of this square by doing the inverse of a square, which is called a square root. Okay, so the square root will cancel out the square. So those will cancel each other out. So those would cancel, and it would become just an x. Okay, so in this one right here, to get rid of the square, we're going to do the square root of both sides, which will cancel that 2 out, and we'll have c equals, and let me show you where the button is. So you can use the standard or you can use the scientific. So I'll show you in both ways. So here's the square root right here. It'll have the little 2 in front. That's just showing you that that is what goes with that. So type in 169 square root. And then in the scientific calculator, 169, oh, you know what? I don't see it in here. Okay, so you might need to stay in your standard for that and click that button. So your answer is 13. Okay, so that's for that side length. Okay, so another type of question that you might run across is where you have the C, let's say this is 12, let's say this is 3, and let's say we don't know what that is, and they give you X. So we're still using the same theorem, but we've already been given our C. So instead, what we're going to do is we're going to say, we don't know what A is. I'm going to make that into an X. You can keep it A if you would prefer. So I'll write it both ways. I'll write X squared over there, and I'll write A squared over here, plus B, which is 3 squared, equals 12 squared. Okay, so X squared stays the same. 3 times 3 is 9, and then 144. A squared plus 9, oops, no square on there, 144. Let me erase that little mistake. Okay, and then you could solve by subtracting. Just like that. 135. A squared equals 135. Okay, and then you could take the square root from both sides. And then I'm going to have to put my answers up on top. So X equals, or A equals. Now, this is not going to be a perfect square root. So if you come out with a decimal, okay, and you did plug it in correctly, the best thing to do is to have 2 decimal points. So 11.62. There we go. Okay. So some teachers like to keep it as A, and some teachers say it's okay, you can change it to an X. So if you are somebody who gets really confused with other letters, change it to an X and just put X equals the whole time. Okay. But if you prefer to see that A plus B plus C, change it to an A.